Some formulas in row 4, also over in column H and column I. Formulas many times are straightforward, simple, easy to use, but they start with a different concept than you might be familiar with. In cell B4, we want to subtract the two numbers above it. Now, if that's all you were told and you never work with Excel, you might be typing something like 120 minus 100. But in Excel, typically we write formulas based on location, and that implies content. One way to state this is we are about to say that cell B4 equals whatever is in B2 minus whatever is in B3. Now, we don't need to type B4. We're already at that cell. We type equal. Formulas in Excel begin with equal. Now, there are a few different ways to enter formulas. The most common way, at least initially, is to type addresses. B2. And what we're saying, in effect, is whatever is in B2 minus whatever's in B3. We'll type B3. This opens the door for the possibility that later, if we need to adjust those sales or overhead numbers, our formula will react automatically. So we complete the entry with Enter or Tab or any of the arrow keys. That's it. We've got a formula. Now, get used to the idea that when you click on a cell, keep your eye on the formula bar. And it really starts to become important as you work with formulas. Anytime you're looking at a worksheet, you click on a cell, you see in the formula bar, is it a formula? Is it not? You develop a sixth sense at times about which cells have formulas but which don't, but that immediately confirms it when you click on a cell. Now, another way to write this, not necessarily better, but it does not involve typing addresses. So I'm going to delete this entry. I'm going to type equal and then press the up arrow twice to get to cell B2. And we see that in the formula already, equal B2. Then I'll type minus and press the up arrow once, and you see the formula, equal B2 minus B3. That's all we need. Enter. So the advantage, it might have taken a tad longer, but on the other hand, we didn't type an address, or possibly worse, we didn't mistype an address. Same formula here. If you look in the formula bar, you see it. If you double click in the cell, you see it as well. A third way might involve using two hands. It could be faster, even though that might sound a little unwieldy. I'm going to delete this and start over. This time I'll type equal, click cell B2, type minus, click cell B3, and press enter. Same result in all three different methods here for entering the formula. It's just a question of what works best for you. Either typing the entry, using arrow keys, or using a combination of typing and mouse. Now, if that's all you had learned about formulas, and you went to cell H2 to put in a total here, you would probably begin this way. Type equal. We want to add up those cells to the left. We could put in B2, and then a plus, and then C2, and a plus. I'm not going to finish this, but I could, if I wanted to, put in D2 plus E2 plus F2 and so on. Imagine how unwieldy this is going to be, not only here, but what if we were doing 12 months? This, although it could produce a correct answer, is certainly not the best way to do this. So let's get rid of this. Built into Excel are what we call functions. There are over 450 of them. A capsule description of what a function is, it's a shortcut for a formula. That doesn't apply in every single case, but that's a general definition of what a function is. On the Formulas tab in the ribbon, you'll see all kinds of functions listed here in various categories. Now, the most common function in Excel is sum for nearly everybody. I'm going to start typing in cell H2 equal sum. Now notice what happens when I type the letter S. There are lots of other functions that begin with the letter S. Sometimes you see one here and there and you know what it is. Other times you get a little curious. We're not, say, at that point just yet. And we don't have to necessarily scroll up and down and see these. And this is so short, we're not going to take advantage of any way to type this in any faster. Let's type equal sum, left parenthesis. All functions are followed by an open and closed parentheses. Now, you wouldn't know what to do next necessarily, but with the mouse, let's highlight cells B2 through G2. And you can either drag leftward or rightward. Wherever you start, for example, I'm going to start in G2. I'm pointing in here, hold down the left mouse button, drag leftward into B2. I said that all functions are followed by open and closed paren, But Excel does this for you if you're only using a function by itself. So I'll simply press enter. And we've got an answer there. And you could certainly verify that. And by the way, if you do highlight these cells, your status screen at the bottom of the screen probably gives you that total as well. Now, if you've deactivated status bar or if you don't have some of the check marks set up, you won't see the total there, but that verifies that it's working. For an average right here, if we want to know the average of these first 6 months, we need to add up these entries and divide by 6. But we've already done the addition right here. Now remember, when you click on a cell, get in that habit of looking in the formula bar to remind you. That may look like 1505, but in a certain sense, it's not that at all. It's a formula, in this case, to be more specific, a function that adds up the 6 cells to the left. The average here, we simply need to take that value, H2. Now you can type it, or in this case, possibly equal. Click this cell, /6. If you are typing, you don't need to capitalize the H. If you click on it, it's automatically capitalized. Slash is the division symbol. Now this is the slash that on most keyboards is in the bottom row, usually a few keys to the right of the letter M. You cannot use the other slash, the one that goes in the opposite direction. Equal H2 divided by 6. So in our examples here, we just used division here. We used a sum function here. Our original formula over here in cell B4 used subtraction. We haven't used the multiplication symbol, it's an asterisk. But we're seeing some of the basic building blocks here of how to build simple formulas. And again, remember different techniques. Many people will simply type the cell addresses, but whether you use that technique or the technique of using the mouse and the keyboard together, writing formula is something that's very important as you work with Excel. We're looking at a worksheet called Copy Formulas in the workbook 03-Creating Formulas and Functions. A formula is written in cell B4. Remember, if the cell is selected, you can see the formula in the formula bar, or if you've zoomed in, as this particular worksheet has been, you can double click here, perhaps see it a little bit better, and it is color coded. Now, we need to do this for February, March, April, May, June. Possibly in a similar worksheet, we might have 12 months here. We don't want to be retyping this kind of a formula many, many more times. In Excel, it's not uncommon that after you've written a formula, you need to copy it either rightward into adjacent cells or downward. And it's a huge time saver to be able to do this. Now, the formula that we're seeing here, and I'll double click it again, is B2 minus B3. We certainly do not want to see that formula right here. But when you copy a formula, Excel does what we would want it to do. In other words, and if we think of this formula in a different way, this is a formula that subtracts the 2 cells above it and in a certain order. Do we want to do the same sort of thing here? We certainly do. The formula to our left does what? The cell that's up 2, we want to take it and subtract the cell that's right below it. Over here, same idea, this cell minus this one. So when we copy a formula, Excel in effect is saying, I see you're moving rightward 1 column. I'm going to take this formula and adjust the column references. So if we move rightward 1 column from column B, we're going to see a formula over here that's going to be C2 minus C3. And that's what happens when you copy a formula. And we copy formulas from the lower right-hand corner, the so-called fill handle. Remember, to slide over that, the mouse pointer turns from a 3-dimensional plus into a thin plus, like crosshairs. We'll hold down the left mouse button on the fill handle and drag rightward into June. And you can see the answers pretty readily are accurate. If we click on this cell, maybe double click just to check it out, we see what's happened. Press escape over here, double click, we see what's happening. Copying formulas means we copy, you could say, the relationship. This formula subtracts the 2 cells above it. All the other places that we copied it to, what do the formulas do? They subtract the 2 cells above it in the same way. Now, similarly, in column H, in cell H2 right here, I'll double click, we've got a formula that adds up the 6 cells to its left. Do we want to do that below this in cell H3 and H4? Yes. We'll do the same kind of thing. From the lower right-hand corner, we'll drag downward and get answers there. What's the formula here? Double click, you can see it better than in the formula bar, although it's there too. We're adding up the 6 cells to the left. In cell I2, we've got a formula that takes the data in the cell to its left and divides by 6. Do we want to do the same thing just below it? Yes, we do. And below that, same idea. We'll drag this downward. For the moment, let's say we don't care about the decimals. Eventually, we would clean that up. But the main idea here is, in this worksheet, we started off with seeing only 3 formulas, one in B4, one in H2, one in I2. We simply created the other formulas by copying. And it's very, very common in Excel to write a single formula and copy it into many, many cells rightward or many, many cells downward. And it's a real time saver. In this worksheet called YTD and percent increase, we're going to put in some formulas in row 5 here that calculate our year-to-date profits. A relatively simple formula, although one that can be a little tricky and one that brings out the idea of cell references and how we work with them in Excel. In cell B5, our year-to-date profit so far is simply the same as the number we see above it. Now, we could type a 20 here, and that might look correct for now, but the profit above it is actually a calculation showing sales and overhead difference. What if those numbers get changed? For example, we find out that maybe the sales number is 125 or the overhead is 125. We have a negative possibly here. What would happen then to the 20 that we just typed in here? It would stay the same and it would be incorrect. So what we really want here for January, and January only, is for this always to be equal to the cell above it. Now, as we're looking ahead toward February, we don't want that kind of a formula there. In February, our year-to-date profit will be 50. So let's go back to January here and make this formula be equal B4. You can simply click on it or type it. Either way, press enter. And so that means if we adjust overhead, maybe our expenses were a lot higher and they really went to 125. As I type this in place, both profit and YTD profit below this will change. In this case, it's a negative, which we hope not to see, but that's what happened. So I'll undo that, Control Z. Now, as we look ahead to February here, we know the answer is going to be 50. How did I get 50? I added these two. But now I'm thinking, as I look toward March, if the February year-to-date is going to be the sum of these two, if I write a formula here that adds those two, what happens if the formula gets copied here? The March year-to-date will be 80. And yet by the end of March, we will have made 100. Now, we could think of these as dollars or thousands of dollars, but the main idea here is, as we move rightward here, we don't want to just be adding up the last 2 months. We really want to be adding up the current value, the current month, added on to the previous year to date. So remember, we could get the answer 50 here by adding these 2 cells or by adding these 2. And the more you think it out, the more you recognize we want to be adding these 2 cells, not these 2. And as we write this formula, it makes no difference which one we mention first. If you use the analogy of I'm depositing money into a bank, so I want to add it to my previous balance, then here's the deposit or the new number plus our previous balance this way. So however you want to think it out, just remember the idea. We're adding on to what we already have. And so our answer here is 50, 30 plus 20, these 2. And if we drag this to the right using the fill handle into column G, we should have correct answers all the way across. And this value that we have right here should be the same as that. And it is. So one by one here, we see what's happening. Not a difficult formula, really, maybe a little tricky at first, but it's something you learn to deal with. It emphasizes the idea that the formula here, which is adding the cell above and the cell to its left, when we copy it, we're copying that same kind of relationship. So every one of these formulas here is adding the cell above to the cell to its left in each case here. So in this case, it's going to be G4 plus F5. That's the way it is. In this worksheet called YTD and percent increase, we need to calculate the percent of increase of our profits from month to month, or possibly the overhead, or possibly sales. And is increase really the right word here? Maybe it isn't. So let's do some editing. It's going to be a change. I'm going to double click in cell A6, I'm going to double click right on the word increase. And once editing has begun, I'm going to double click again and simply put in the word change. Now, maybe I'm an optimist and that's why I put in increase, but on the one hand, we want our profits to increase, but maybe not our overhead. Nevertheless, we've got our entry there. Now, percent change for January is not going to be meaningful because we have no previous number to compare it with. But looking into February here in cell C6, we need to calculate percent change. Now, it might have been a long time since you've done this, probably something you learned back in the 8th grade or high school. How do we calculate percent change here? If we've grown from 20 to 30, what's the percent of change? The way we do this is to calculate first the difference here, and then we divide it by the number that we started with. So let's begin this as a formula. What this is going to reveal is one of the most common errors in Excel. It's one that's easily overcome, but on the other hand, it's something that can bedevil you if you're not careful. If you work with standard calculators and you're working with the real numbers here, you could punch in 30 minus 20. And then if you wanted to divide that difference, you put in a slash key, it would be displaying a 10 on your screen. Then you divide by 20 and you'd get a correct answer. But what happens here in Excel? I'm going to type equal. And as I said earlier, the way we calculate this is to take the difference of these two. So it's C4 minus B4. We know that answer is 10. Then we divide it. Here's the slash key. Remember, this is the one on the lower set of keys near the letter M to the right. We want to divide this by our starting value. And we would be expecting to see an answer here, if that difference is 10 and we're dividing by 20, to see an answer like 0.5, which is the same as 50%. But when we press enter, it might be a bit of a shock. It's 29. So what's happening here? Now, what you won't see on your Excel worksheet unless you put it there are the symbols we're seeing in cells A8 down to A11. These are some of the symbols, not all of them, but most of the symbols that we use as we write formulas in Excel. The order in which we see them here is sometimes referred to as the hierarchy of operations. Let's go back to this formula. When we complete a formula like this, Excel, in effect, is saying, what's the first symbol that I see as I look down my list, starting in A8, that appears in the formula? The first thing we see is the slash key, the division symbol. So what Excel does is the division first. B4 divided by B4 is 1. What's the value in C4? It's 30. 30 minus 1, that's why we get a 29. Now, as you look at the list again, notice what's at the top, parentheses. So I'm going to go back to the formula, double-clicking in cell C6. And right after the equal sign, I'm going to put in a left parenthesis. And then after the first B4, I'll put in a right parenthesis. Now, before pressing enter, when Excel sees this formula, what will it do? Looking down its list, I see parentheses first. What do? It will perform the calculation in here first. Within the parentheses, that value is 10, and then it will divide that by the value in B4, which is 20. Now we're about to see the answer we expected, 0.5. And right away, most of us probably would change this to read by going to the Home tab. There's a percent button right here in the number group, like that. If you wanted to show an additional decimal, which you might want to do if the numbers are smaller, you can increase the decimal this way. So this formula is based on the cells that are up above 2 cells and then 1 to the left. So if we copy the formula here, it will deal with this relationship, and the formula here with that relationship, and so on. So we'll copy this across. And in some cases, we see 0. If we grow from 50 to 50, well, the percent of change is 0. And we see the other changes. And you can imagine how valuable a formula like this is over time, month after month, year after year. You can see fluctuations seasonally perhaps, or other reasons attributing to that. But calculating something like this, pretty straightforward, but it brings out the idea that we must use parentheses at certain times. It's quite common in Excel when formulas are not working, that's what you should be looking for. Many, many times you either forgot to put in parentheses or you put them in the wrong place. Now, a lot of people overcompensate. I've seen people, for example, say, all formulas have to begin and be surrounded by parentheses like this. Well, that's not true, and this is not really a requirement, but it doesn't hurt in this case. It's just unnecessary. We would still get a correct answer. Or coming back here again, I'll press Control Z to undo it. What if we put parentheses around the B4? That's okay too, but not necessary. But when you forget one of them, in other words, they always must be matching left and right in addition to being positioned correctly. Sometimes you'll get an error message that's helpful, sometimes not. So I'm about to press Enter here, and notice the fact that the parentheses are not matching up. We don't have an equal number of left and right. Enter. And Excel comes back and says, we found a typo. In this example, it is suggesting something that will work, although its suggestion is overkill. They could have suggested to take out that last parentheses that's in front of the final B4, but nevertheless, that works okay. In my experience in working with formulas, when there's a correction to be made and Excel makes a suggestion like this, I'd say about 90% of the time it is making a correct suggestion. So in this case, yes as well. Now, although we're not going to be covering formulas in detail right now, there's one particular situation here that you want to be alert to, and you'll just have to intervene and possibly do some research on the if function, which is covered later in this course. But if the profits here go below zero, I'm going to change the overhead here to be 260 and press Enter. We then have some results here that just make no sense at all. For example, this number is comparing percent change here. That's not a viable number. And this one certainly isn't. If your profits are minus 10, they go to 65. You'll see what's happening here. So in some cases, and you want to be alert to this, these numbers are just totally inappropriate. Let me press Control Z. But if these are the same, we do get 0%. That is an accurate number, and so is this one to the right. So I've seen the example here of the kind of formula that you need at different times in Excel. I'm not suggesting, by the way, that everybody needs to know how to do percentage change, but I think it's quite commonly used. And it's one of those many formulas that we probably have all done at one time or another. We just forgot how to do it. But remember, the key idea in many formulas is we need to use parentheses and we need to put them in the correct order and location within our formulas. We're looking at a worksheet called Absolute in our workbook 03-Creating Formulas and Functions. In cell F2, we're about to calculate a new salary, not only for Lisa, but for all the others in our list here. Now, if everybody's going to get $2,000 more, we could write a simple formula here, equal E2, type it or click it, plus 2,000. And we can copy this down the column. Even before pressing Enter, we can point to the lower right-hand corner, click and drag downward, and that formula will have been copied downward. And our original formula, E2 plus 2,000, has been copied here automatically to say E3 plus 2,000. And this is what we call a relative reference. As we copy a formula into a different row, the row reference in the formula, the row 2, becomes row 3 and becomes row 4. And down at the bottom, row 13. That happens automatically. It's referred to as a relative reference. But what if our salary calculation is going to be based on a percent increase, 2.1%? Instead of this formula, we're going to make a change to it. So in cell F2, and I'll just start all over again, equal E2, asterisk meaning multiplication, H2. Now, if I press Enter, I will only get the amount of the increase. It'll look like this. That's the amount of the increase. So we want that incremental value to be added on to the existing salary, plus E2. Now, there are different ways to write this formula. Some people will put this in parentheses, but change the E2 there to be a 1. We can certainly do it that way. And there are a few other ways as well, too. But the point is, we will get a correct answer here. The new salary for Lisa will be $55,695. If we copy this downward, all the way to the bottom, as we look back and forth, we realized only Lisa is going to be happy with this pay increase because what's happened here and every other cell below, the numbers have not changed. So what's the formula in F3? Correctly, the references to cell E2 have been changed, but the reference to H1 got changed as well. It becomes H2. And as you might guess, down here, for example, this refers to cell H7, and down here it refers to H10 and so on. Now, a poor solution here would be to fill in all these cells with 2.1. You can imagine a list like this maybe having hundreds, thousands, or tens of thousands of names. That would not be the best way to do this. So here's a situation where we do not want that reference to H1 to be a relative reference. We want it to be absolute. We want this location to be more precise, not to change. So a reference is made absolute by adding dollar signs, and that is not intuitive or at all logical. I wouldn't call it illogical, but if we put a dollar sign in front of the H and in front of the 1 here, that means it's an absolute reference. Now, you could mistakenly be saying, oh, I get it, dollar signs salary. I see what's going on here. That has nothing to do with it. The dollar signs as we use them here mean if we copy this formula, this reference will not change. This is referred to as an absolute address. Now, instead of typing the dollar signs, what you could do, and if you saw this coming before writing the formula, you would know ahead of time, right after the H1, you can simply press F4. Now, when you're editing, you could click in front of it, you can click between the two, any of those, makes no difference. But when you press the function key F4, Excel does the typing for you. And again, I stress, this is not intuitive in any way. It's the action we take to make sure that this formula, if it's copied, this portion of it will not change. So we want to copy this from the lower right-hand corner. And if I press Control-Enter, the active cell will not move down. It'll stay in place. And I'll drag from the lower right-hand corner down the bottom. The salaries have all gone up. Let's click any one of these, double-click here, we see what's happening. They all refer to cell H1. Now, if we were just writing the formula for the first time, and we know that we need that, equal E2 times H1, at that point, we'll simply press F4 and then plus E2. So more and more, you'll see the need for this. Anybody who uses Excel with any kind of depth will need this feature at one time or another. It's called an absolute reference. In certain situations, and it's beyond the scope of this course, you will have the need to make sure that just the row reference is absolute. So you might have a dollar sign just in front of the row reference, or in other cases, just in front of the column reference. And it could be the case actually here, we really only strictly need a dollar sign in front of the row reference because we're not moving or copying our formula into a different column. So we could get away with not having the dollar sign in front of the H. But it's so simple to apply these with the F4 key. Doesn't hurt in this case, works just fine. It's an absolute reference and it's absolutely indispensable as you work with Excel. In this workbook, O3, Creating Formulas and Functions, we're looking at a worksheet called Sum Average. Sum and average represent two of the most commonly used functions in Excel, and there are some shortcuts here. If we're about to create a total in cell G2, we can use the function sum. We can type equal sum, left parenthesis, and highlight these cells, and press enter. We've got an answer. Now, potentially a faster way to do this is to use a feature called the Auto Sum button. On the Home tab, you'll see it here off to the right in the editing group. There's Auto Sum. Notice there's a keystroke shortcut referred to below it, Alt equal. If we click Auto Sum in cell G2, Excel says, I see numbers to the left, let's add them. Press enter, we've got our total. That's likely to be faster than typing in the entry. Now, you could get there a little bit faster. Why not just double click Auto Sum? There we are, rather than pressing Auto Sum and then enter. If you press Alt equal, you will have to press enter. But at other times, that could be faster too. You'll also find this Auto Sum button on the Formulas tab. It's off to the left, a bit larger. Double click it, remember, slightly faster. If you want to see the formula though, and sometimes you do, you just click it once. Second time brings it in. We can do the same kind of thing in cell B9. The Auto Sum button is designed to add up data from the left or from above. Now, we could position the active cell in B9 and press Auto Sum or Alt equal, or possibly we could even highlight the data ahead of time. And in our previous example, we could have highlighted the data that way too. The advantage of highlighting ahead of time is we need only click the button once or press Alt equal. Either way, I'm pressing Alt equal, there's the total on the bottom. An alternate way, but no better, as I press Control Z to undo, is to highlight all these cells here. press Alt equal. There's a total. Now, here's a situation where we've got cells above the empty cell and to the left. So if we position the active cell right here in H7, what does AutoSum do? There's the AutoSum button. Remember, pressing this or Alt equal, do the same thing. It's trying to add data from above. I want to add the data from the left. I'll simply use the mouse and highlight these 3 cells. In other words, I'll override what it wants to do. Anytime Excel sees data above and to the left, it favors the upward direction and tries to add up that data first. In the list down in rows 12 through 15, if we only wanted totals here on the right here, we could highlight these cells, press Alt equal or the AutoSum buttons in either location. There's a total. If we wanted totals at the bottom, we could highlight these cells, do the same kind of thing. Alt equal, there we go. Let me undo both of those. If we knew ahead of time that we wanted totals both on the right and below, we could highlight the data this way and simply press AutoSum or Alt equal, and we get totals that way. Now, there's some other aspects of this too that could be faster. Instead of a total up here, what if we wanted to know the maximum value? We'll just put in the heading there. I'm going to click not the AutoSum button itself, but the arrow that's associated with it. Here it's below AutoSum. On the Home tab, it's to the right. Click the drop arrow. I want to choose max, meaning maximum. Enter. There's the highest value in the list. So we can use max or min. Or how about going back here where we had totals here on the perimeter? Let's take out these, delete, highlight these, delete, and select this area. But what if we wanted to do an average? I'm going to click the drop arrow associated with AutoSum and choose average. And now I've got averages on the right and below. We'd reformat those eventually, but these are all averages. So these are averages of cells to the left, like this. These are averages of the cells above. And the one in the corner is an average of the cells to the left. Now, if you want to add data from different locations, you can also do that with the sum function. What I'm about to do would certainly be unorthodox because I would like to add some data from this group and from this group over here and maybe from some data down here. And rather than typing equal sum, which I certainly could do, I'll just start with Alt equal. I'm ignoring what Excel is suggesting though. I'm going to highlight these 2 cells up here, D2 and E2, put in a comma, and over in column B, highlight those 2, put in a comma, and maybe come down to this lower list. Now granted, who would be adding up cells like this? Probably nobody, but it does point out the idea that we can build the sum function to gather data from different locations. And if you start with Alt equal, you just save yourself the effort of typing equal SUM left parenthesis. So it makes it a bit faster. And enter. We've got our total. So the AutoSum button, its keystroke shortcut, Alt equal, and the occasional use of that drop arrow really makes tabulating sums and averages and occasionally other functions very fast and efficient. Built into Excel is a huge library of over 450 functions. We're looking at a worksheet called Functions in our workbook 03-Creating Formulas and Functions. If you go to the Formulas tab in the ribbon and slide over one of the entries here, you can see there are different kinds of functions. And as we slide over this one or that one, we can see a pop-up tip reminding us or explaining to us what it does. And there's a lot of them, as I suggested, math and trig. Now, with the wrong mindset here, you could easily get overwhelmed. Here's one on inverse hyperbolic cosine. Do you think you'll need that one? I kind of doubt it, unless you're in the scientific arena. And of course, there are some valuable tools and functions in here. Do you work in finance? There certainly are some financial functions here, quite a few of them, about 50 of them or so out here. A capsule description of a function, what is it? It's a shortcut for a formula. Now, each one has to be taken on its own merits, and you'll see tons of options here for using these. Under more functions, you'll see a category called statistical, and that's pretty huge as well. In this worksheet, we've got some information over in column J. Maybe this is a description of things we might want to do with some of the data we've got here. Now, we don't have a lot of data here, but you could easily imagine a list like this being huge. And here's the word rank too. Let's take a look at that idea. If we want to rank these salaries, in other words, compare this one with all the others, as you might guess, there's a function called rank. Now the question sometimes comes up, how do you know if there's a function? Well, sometimes you don't. You may have overheard somebody use the word or the phrase, or maybe you just happened to see it up there one day as you were looking around at different functions. As you type a letter after the equal sign, all functions that begin with that letter appear in this list. And sometimes just by looking at it, you get ideas about functions out there. Here's one called rank. Now, interestingly enough, this is an odd one in the sense that here's one called rank average, and there's a description. Here's one called rank EQ. And there's one left over from a prior version, simply RANK, which you don't see in the list until you happen to type it. And there's a little note there. We won't go into this right now, but this function says, in effect, I've got a value right here, comma, and I want to compare it with all the other values in a list. Now, sometimes in formulas, it's handy to select an entire column. I'll just click column F, and I'll press enter. So that's the 8th highest entry. That's what the rank function does. It says, looking in this list, this is the 8th highest. We can drag this down the column, and we can see, because it's a relatively short list, that it's correct. That's the highest value right there. Here's the second highest. If two of these values are the same, if we use the simple function rank, we'll see that they share the ranking. So I'm going to make these two salaries here be identical for the moment. I'll do that. We see they share the number 5 position, but if you look in the list here, you don't see a number 6. So in effect, they're occupying the 5th and 6th positions. There are two other variations on the rank function you might want to take a look at. Over here are some other ideas. Count data cells. Well, how many people do we have? Well, that's pretty easy, but there is a function that counts the cells that have data. Equal count A. Now this counts all cells that have data, not just numeric data. So how many of these cells here have data? That's probably not that useful, but this will tell us it's 72. Now that counts numerical cells. What if we wanted to count just the number cells? Equal count. And if I were to highlight these cells, of course, a lot of those do not contain numbers, but some do. Only 48 of them contain numbers. Now, you could say, in this case, that's just trivia, and I'd sort of agree with you, but sometimes that's important to know that. Median, on the other hand, is something that's valuable. It's similar to average, but certainly not the same. Median says, let's take the middle value in a list. And if the number of entries is even, it will average the middle too. So equal median. Now, once again, how do you know there's a function called median? Well, it's a good guess, let's say. Excel has a lot of statistical capability. But if you happen to be going to the Formulas tab, clicking More Functions, go to Statistical, you're going to see median out there. And if you don't find it, what's your other guess? You will find it here, and there's a description of it too. Sometimes, of course, you'll just have a sense, as we did in this case, there's a median out there. Left parenthesis, what's the median of the new salaries here? We could click column F or just these cells here. That's the median value in this list. Now, second largest, I didn't think I needed this, and I've only needed it a few times over the years, but I happened to discover it about 15 years ago. Came in really handy a couple of times. Is there a function for second largest, and what would it be? I can tell you what it is, but how would you discover it? Is it math and trig? Well, you might see it this way. Out here, it's not under math and trig. Maybe it's under statistical. Sometimes you just don't know where to look. Now, there is an option here. You could, for example, over here, insert function, and actually type in second highest, second largest, and click go and see what happens. Now, it alerts you to a bunch of functions here, maybe more than you'd like to explore. As it turns out, in this case, it is called large, so we'll just cancel out of here. So equal large. Now, again, I'm not saying necessarily that's something that everybody needs. It just points out how valuable certain functions can be. You just don't know all the time where to look for them. An example here, I'm looking here, and I want to know the second largest, so I'll put in the number 2, 3 for third largest, and so on. And as you might guess, there's a similar function, does the opposite, and it's called small. In this case, we want to know the second largest salary. It doesn't tell us where it is, but we can easily see it in the short list. There it is. It's Maria Perez in row 11. That's the second highest entry there. STD, standard deviation, but you wouldn't know that necessarily either. Now, once again, how do we know this? How would you guess it? You would probably imagine that if Excel has median, if it has averages, it's probably got standard deviation. If you were looking, you'd find it under statistical functions, but even if you start typing, no doubt it begins with ST, And right away, you see a group here, and maybe more than you would have expected: STDEV, P, S. And if you are about to use this, you probably have a sense of which one is the one that you need. And by the way, sometimes what you'll do once you find the one is just tab it into place like that. Refer to the salaries this way. And if you know what standard deviation means, you're getting an answer that makes some sense. It gives a weighted average to the differences between these salaries and the average. So lots of functions out there, a ton of them. Again, don't spend too much time just spending idle time looking for a function, but the more you work with Excel, the more you begin to have a sense of what some of these are. And keep in mind that some of you will never look at math and trig. Some of you will look at that a lot, depending upon where you work and what you do. Lots of other functions. When you have that extra minute, maybe check out this one, check out that one. Over 450 functions in Excel, and they're absolutely indispensable for many Excel users.